So we found to solve this graphically, that was over here, we could see that 2 and -1 were the zeros. So now I'm solving it algebraically. You take f of x, you set it equal to 0, which is what I've done here. How do I solve this? This is kind of a weird looking creature. We're going to use something called the zero product property. And I think you know this property. This is a property that says something times 0 is 0. You know that property?
Yeah.
So look how it's written here. It says if you are multiplying two things, like an A and a B, and it works for more than 2 things, or 3 things, or 4 things, or however many things you want to multiply, if it equals 0, what has to be true of A or B? What do you?
One of them has to be.
One of them has to be 0. So it could be that this one, the A, is 0. Because 0 times anything is 0. Or could be B. So how many solutions are there to this thing? 2. Hey, hold it up with 2 fingers. 2 solutions to an equation. Now we're not used to that. We're used to only 1 solution to an equation. That's a linear equation. Remember it has 1, 0? Well, now we're looking at a different kind of equation. It's going to have 2 zeros. Somebody asked what happens if they're both zeros, so then what's the 1 solution? There's only 1 possibility. And we saw a case where maybe there is only 1 solution. That can happen too. But in general, like in this one, let's compare that with our zero product property. I'm multiplying one thing by another thing. I'm multiplying 2 binomials. So this is like my A. So what makes this 0? Well, this whole factor could be 0. Or this whole factor could be 0. If this is true, this thing is 0 right here. Isn't the whole thing going to be 0? The 0 times anything? Or if this one is 0, something times 0 is 0. So now what we do is we solve this for 0. And we can solve that equation by subtracting 1 from both sides. This one I can add 2 to both sides. And now I have solved a strange looking equation that we've never really seen one like this before. But we can solve it because we know that they both could be 0. So what are my solutions to this equation? X equals -1, x equals 2. How did this compare to the zeros of this function? What were the zeros of this function? Same thing. So, and that makes sense. I think it makes sense because we know how to find zeros of a function. You take that function, you set it equal to 0, you find the roots of this equation. We're using all those words, the zeros in the root, and we get x equals -1 and 2. So the zero product property can make things easy. Now if I look at, I'm going to pick this one. No, not good. X times x, I'm just multiplying that here, times -2x plus x minus 2. I combine this. I just did a bit of multiple distribution. So if f of x is this thing, say, then isn't f of x this thing? Aren't they equivalent? They are equivalent. So when I say find the zeros of this, that would mean setting this equal to 0. This is the thing we don't know how to do. We tried it. We couldn't figure out how to isolate x. But it turns out it's the same as this. I found 2 factors that are the same thing. I can use the zero product property to find the values of x and solve the equation that way. So it's kind of a sneaky way. This is called the factored form of that equation. When I am in factors, it's much easier to solve. So we're going to be spending a lot of time learning how to go from here to here. That's what we're going to be spending time doing. Before we do that, though, I do want to make sure we're good with using that zero product property. These are you tries, but let's just do them together here. If I have x minus 3 times x plus 6, the whole thing's 0. So how do I solve that particular equation? How do I solve that? Exactly. X equals 4. So you see what he did there? You take each factor and you set it equal to 0. Because if they're 0, the whole thing becomes 0 and we're solving it. This is a much simpler thing to solve. Let's try this one here. Somebody else want to try that guy here? Do you want to try this one for me? So, how would I set this up?
N minus 0.
Yep.
And N minus 0.
Excellent. Then what?
Then solve it.
Okay. So what do we get for this side?
N equals
N.
N equals 7.
Yep.
N equals 9.
So there are two solutions, 7 and 9. Anybody noticing any relationship here between what we're getting as solutions and what we're looking at in the factors? Now, what do you see?
That the solutions are in opposites.
They are opposites, because I want this to be 0, and any number plus its opposite, right, is going to be 0. Now, that's great when they're like that. These are a little bit harder to see when I look at this example. So just go ahead, do the same thing. Set each factor equal to 0, and then solve each equation. This equation is slightly difficult, but not terrible. Subtract 10 from both sides. Divide by 5. N equals -2. And look, if I plug -2 in here, 5 times -2 is -10. Plus 10, 0.
Oh yeah.
Then I'm going to subtract 12 from this side, because I want to solve it for n over here. Divide by 4, and n equals -3. If I put in there 4 times -3, that's -12 plus 12, 0. So even when they're a little bit more complicated, they're still linear in nature. We're very good at solving those equations. Who's with me so far? It's not so bad. It's not so bad. Okay. So we get into the big time now. We're gonna again the whole problem is how do I go from here to here? How do I factor? And that's what we're gonna start talking about. What are factors first? Definition. Something that you multiply. 2, 3, 4, 5 things. N things that you're multiplying, those things are factors. Excellent. Now we also talk about prime factors. Prime factor. One person, oh please, you all know what a prime factor is.
Oh.
Oh, hang on, I want to give everybody a chance. What's a prime factor?
It's a prime number.
Yeah.
It's also a factor.
What's a prime number?
9.
9 is not a prime number. What's a prime number?
Come on.
It's not.
Come on.
4 is a prime number.
4 is not a prime number.
I know.
Do you know, Mary? Oh, there's just something special about the multiplication. I'll give you that. Do you know? By 1 in itself, right? So why is 9 not prime? Because 3 times 3 is 9. So that's not just 1 in itself. Give me an example of a prime number. Example of a prime.
3 double.
3. Yes, 3 is a prime
I'm
number.
not going to count 1 as a prime number since it's
You don't count 1, but what about 2?
prime.
3. What else? 13. Yeah. Yeah. Oh, I was going to use 7 and I ran out of primes. Do you have another one you can think of? 23 is a prime number.
11.
13.
All right, 48.
Not a prime number. No. Yes. So you divide by 2. You got one? 11. 17.
47.
47, I believe you're right. Which one?
447.
That was a guess.
I don't know. It could be. I don't know. That's a big
I'll
one. I'm
check.
not sure.
All right.
It could be.
All right, I got one. Yeah, he's right.
You got one. I'll give you one more chance.
81.
Not a
Come on,
prime.
Zach.
What's a prime number?
Prime number 1 in itself. So 81, 9 times 9 is 81. I can't use that one. But 17, 1 times 17 is 17. Is there anything else that I can multiply to get 17?
No.
No?
Okay.
Wait just a
So
minute.
that's what a prime is. So,
9 times 9.
remember you guys did this? If you want to get the prime factors of 6, what are the prime factors of 6? Go ahead. 2 times 3, right? So we break down a number into its primes, and we multiply to get them. Now what we're going to be doing with polynomials is the same kind of thing. We're going to factor the polynomials so that it's a product of what we call prime polynomials. And a prime polynomial is one that I can't factor anymore. And in general, they are of a lower degree than what we're starting with. So what? So I'm looking at these two factors, x plus 1 and x minus 2 are factors. What are they factors of? And to figure that out, let me ask you a different question. 7 and 2, what are they factors of?
14.
14. How'd you get that?
Or, I multiply.
You multiply. So we can multiply here too. And let's see, minus 2x plus x. These are the factors of that. So going in this direction, from factor to polynomial expression, pretty easy. Now we're going to focus on going in the opposite direction, starting with the polynomial and going to the factors. Again, why are we doing this? Because it's very hard to solve or find the roots of this equation unless I'm in the factored form. So let's see. We're going to actually be learning 5 different ways of factoring over the next few days. 5 different ways. So we're going to learn the first one today. I call them type 1. You won't see that in any textbook. I've categorized them in a way I've seen another teacher do. Christopher Jefferson in my school. She had a really nice way of organizing these, so I'm doing the same thing. Type 1 factoring is when you factor out a monomial, and it's in quotation marks there because we kind of use that language. We say factor that out. What we're really doing is we're finding the greatest common factor inside of the monomial, or inside a polynomial, and then we reverse distribute. The most important thing that I can't emphasize enough is to verify that you factored correctly by multiplying back, just like we did in the previous example. Do not skip this step. And I've said this over and over when we learned about equations, when we did systems of equations, verify. A few people take me up on it. Most people can't be bothered. It is really, 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 really important, and it's not hard to verify that you're doing this right. So let's look at an example here. I'm on the back now. You're hopefully following along. We're on the back. Here's an example. 6x squared plus 12x. Lovely little polynomial. What's the degree of this polynomial? 2. How many terms? Leading coefficient? Excellent. Okay. Greatest common factor. So here's how we find this, or a way to find it, is first I look at the numbers, 6 and 12. Greatest common factor. Okay, let's review. What are the factors of 6? 1, 2, 3, 6. Factors of 12. Hopefully I got them all. Greatest factor they have in common is 6. Any bills whatsoever. Okay, greatest common factor. Is it ever going to be, ever going to be bigger than the smallest number you have? Remember, it's the greatest number in common. It can't be bigger than the smallest one you have. Won't be. All right, so that's how we work with the numbers. The variables are actually easier. Let's think about this. These are the factors of x squared, and this is the factor of x. What do they have in common? What's the same? What appears in both? X. So we've now found the greatest common factor. You take that greatest common factor, and we're going to reverse distribute. So I kind of draw my parentheses, because what I want to know is 6x times something gets me to 6x squared. So 6x times what gets me to 6x squared? Say nice and loud, loud and proud. X. Now, if you're having trouble seeing it, this is, if something times, if 6x times something is that, you can find it by dividing. 6x squared divided by that greatest common factor is x. Okay, 6x times what gives me 12x? Yeah, what do we get? 2. Now, here's the verification step. I'll be right with you in a second. Here's the verification step that you're not going to skip, right?
Right.
Why would we do that?
Exactly, because I don't have the extra 10 seconds. I mean, that's the only excuse I can think of. Just multiply. Do that distribution, 6x times x, 6x times 2, compared to what we started with. Are they the same?
Yes.
Good, then I factored it correctly. The other thing you look at is in here. Remember I talked about prime factors? You can't have anything else that you can factor in here. Are there any more common factors other than 1? No, then I'm done factoring that. Who followed? Okay, did you have a question?
Yeah, so, dividing polynomials is
Yes, they're very similar. Very, very similar kind of things that we did. What times this gives me that, which is what we did with the division. Same kind of thinking. Alright, so now I want to factor this. So, I look at the 12, I look at the 42. Greatest common factor.
12 6.
No, it's not 6.
Alright, 12, I can't use 12 because 12 is not a factor of 42. So I just, 6 is the biggest one I can think of. Now let me look at the variable. The x and the y, what do they have in common? Nothing. So I guess that's it. 6 is my greatest common factor. I'm going to reverse distribute. 6 times something gives me 12x. 2x. 6 times something gives me 42y.
Oh, 1.
7y. And again, where do we find those kinds of mistakes in our verification stuff? So please don't skip it. It seems like, no, that's silly. I don't need to do it. 6 times 2x. 6 times 7y. Compare that with what you started with. Make sure it's the same. Let's try another one. 4x to the 4th power plus 24x cubed. Greatest common factor. Well, okay, the numbers we get 4. Now, the variables. X times x times x times x, right? That's x to the 4th. X times x times x. What do they have that's the same? 3 factors of x. How do you write 3 factors of x? So the variables are actually easier, in my opinion, because you take the smaller one. So if you have an x to the 4th and an x to the 3rd, what do they have in common? X to the 3rd. So I think they're easier than the numbers. Okay, so you take that greatest common factor. We're going to reverse distribute. 4x times something is 4x to the 4th. Yes. 4x times something gives me 24x to the 3rd. So let's verify and make sure. Because sometimes do I put an x? Do I not put an x? That verify step will help you. 4x cubed times an x. 4x cubed times a 6. Did I get back what I started with?
Yeah.
I sure did. They're the same. And then I also check in here, this is a prime polynomial. There's no other greatest common, there's no other way I can factor that out. It's good. Nothing else in common. All right, what do you think? We're good? All right, so let's keep this in mind because remember, we're factoring for a reason. We're factoring so that we can solve equations. We're factoring so we can solve equations. These are directions. We're going to go over the directions again as we try and solve them. So now I have an equation, 2x squared plus 8x equals 0. I can't use the methods we're used to using, because this is an x squared, this is an x. We can't really isolate the x the way we used to, when it was just a linear equation. So my rules are over here. First you have to make sure all the terms are on one side and zeros on the other. Let's go back here. Are all the terms on one side and 0 on the other? Okay, we're good. I've done that. Then it says factor the polynomial. We're going to factor this. So far we only know how to one method of factoring, which is greatest common factor. What's the greatest common factor of this polynomial? 2. Now let's look at the x's. That's really low, you're right. And then watch what I'm doing here. I am building my parentheses, but I'm not forgetting the equal 0. I am solving the equation. Okay. 2x times what is 2x squared? 2x times what is 8x?
4.
Let's do our quick check here. 2x times x is 2x squared. 2x plus 4, 8x. Do I match? I'm feeling good. Nothing left to factor in here. Now let's go back to our zero product property, which says if you're multiplying stuff and you get 0, each factor could have been 0. So my first factor is over here, and my second factor is over here. I solve each of them for 0. 2x equals 0, what's x? 0, right? You can divide by 2 if you want to. 0 divided by 2 is 0. What about this one? X equals -4. What are the solutions to this equation? 2 of them. Yes?
What do you mean by
I don't see any greatest common factors here, do you? Now, if you don't factor, let's say I forgot and I said it was only x, I would have been left with 2x plus 4. If you look in here, I still have a common factor. I didn't factor it out. So I'm checking here to make sure I really did get the greatest common factor, not just the common factor. Okay, the other thing we can do with this is an equation. How do you verify an equation? The solutions to an equation. How do you do that? Plug them in. So let's do it, right? You can verify that we did this right the same way. Now remember, one at a time, right? 0. So you say, well, if x is 0, let's see if it works. 0. That's a 0. Okay, so 0 works. How about x equals -4? Plug that one in. -4 squared. 16 times 2. 10 times -4. Oh, this is looking good. 0 equals 0. They both work. Two solutions. Awesome. Let's try another one. Oh no. Oh. Wait a second. Let's go back and look what the rules are. Put all terms on one side, 0 on the other. How do I put all the terms on one side? What do I do here? What's your gut telling you to do? Yeah, he's got good instincts. I would subtract this. It is helpful if you keep your highest degree polynomial positive. It's not 100% necessary, but it's easier. It works either way. Okay, so that's the first step. Then it says factor the polynomial. Here's the polynomial. Do I have a greatest common factor? Yes, sir. 3 for the numbers. What about for the variables? You got a y squared to y. What do they have in common? Y. Then I'm going to reverse distribute. And notice I'm putting my equal 0. Don't forget it. Because we're solving an equation. So 3y times what gives me 9y squared? 3y. 3y times what gives me minus 21y?
7y.
What kind of 7?
7y. Or negative 7.
Well, is there a y here? And this is where that kind of working back. If you put a y here, what would you get? You'd get 25y squared. Is that what you got? So that's why we're constantly checking. Does it work? I'm getting 9y squared minus 21y. Have I done it correctly? Yeah. So check it. Because it is, at first especially, you're like, do I need y? Do I not need y? I'm in factored form. It equals 0. By the zero product property, either 3y is 0 or 3y minus 7 equals 0. I can solve these. These are linear. I can solve those. 3y equals 0 when y equals 0. Oh, okay, that's 7. 3y equals 7. Divide by 3. But it doesn't divide by 3. Sure it does. You get 7/3. You just don't get an integer. That's okay. Two solutions, y equals 0, or it could be y is 7/3. Two possibilities will make this true. Let's try this guy. 12h squared minus 36h. So what do I need to do first here? Again, look at what our rules are. All right, how do I do that? Yeah, what do we do? What do we do?
Subtract each by 36. Oh, wait.
Yes,
Oh, yeah.
yes, you
Yeah.
do. Yes, correct.
Subtract each by 36.
I'm going to move him over here. And then I have 0 on the other side. Perfect. What's the next step?
Put it into like
What
distributive
does it
form.
say to do? What does it say to do?
Oh, factor the polynomial.
Factor the polynomial. What's the greatest common factor?
3,
Well, we go a little higher.
6,
We go even higher.
12.
Right? 12 goes into both of them. What about the h's? Just the h. See, the variables are a lot easier than the numbers. They are. 12h times what is h squared? 12h times what gives me minus 36h?
Negative 3h. Or no h.
And again, verify. Let's see. That's 12h squared minus 36h. I do that distribution back just to make sure. Because it is. And at first you may do stuff like that. You're not sure. You put an h in. Do not multiply back. Look here. That does look like a prime binomial here. Now let's say you had done what you said at first. Let's use 3. We would have gotten 4h squared minus 12. Notice how there's a 4 and a 12 because still factored. So always check just in case you don't pick the biggest one first. Okay, let me get rid of that. So we're almost done. What's the next part? same thing, right? Zero product property once again. And if h minus 3 equals 0, h equals 3. Two solutions, h equals 0, h equals 3. If you were to plug 0 in, or if you were to plug 3 in, you would get a true statement. They are solutions. Questions? Yes, ma'am. Just like this. That's good. Some people write them as solution sets. That's okay too. Excellent question. Anything else? Yes. This one? Oh, this one here? When I solved 12h equals 0, I divided both sides by 12. Right, so I get h over here. What's 0 divided by 12? 0. No, we just divided it. And again, 0 product property. 12 times something is 0. Any other questions? These are good questions. All right, you ready for your new tries? All right, go ahead and let me know if you have questions.